Click for IB Biology. Here we're in the ecology section of the course, and we're addressing the transfer of energy and matter through ecosystems. We'll be looking at the so-called open and closed systems, the influence of latitude and ocean depth on energy transfer, and indeed the rules of transfer. Should you wish, there's a blank PDF of this presentation down in the description, and there you'll also find some quick quiz questions to secure your knowledge and understanding of this part of the course. There will be additional channel links as suitable, and there's an AI prompt which allows you to customize some questions for your own learning. So energy transfer and matter transfer in ecosystems. And this topic is going to ultimately allow you to address a question posed by one of the great 20th century ecologist, Paul Colinvaux, who asked the question, why is it that big fierce animals are rare? So here we have a tiger from a Thai forest. Here we have the white-tipped reef shark, again from the oceans around Thailand, where I'm located. And these two organisms are very rare, especially the tiger. And so observation of them is not common. Why is that? And so we start to look into the principles behind energy transfer and matter transfer. So here's the system analysis. So we have Earth here, and the options we have is that we have either an open system or a closed system. Now within an open system, there would be energy coming in, energy going out of the system, and also an exchange of matter. In a closed system, then we would have energy going into and out, but matter would not be exchanged with that system to the outside. So if we look at the Earth as a whole, what we're seeing is energy coming in and out in the form of light, but matter remains on the planet and is going through continuous recycling of that matter, which we might have studied under processes such as the carbon cycle, the nitrogen cycle, and so forth, where the matter goes round and round, being into one form and another under the influence of the incoming energy. The principal source of energy on Earth, of course, is light, and our source is the sun. And of course, we'll be aware from other studies you've done in biology that with light as the incoming source of energy, then plants, producers doing photosynthesis, is the method by which that light energy is harnessed to drive our food chains and our food webs. Perhaps we could think of it in two particular zones of terrestrial systems, and then there are the aquatic systems. In the terrestrial systems, if we have the world here like this, at the equator, light intensity is at its highest, and as we move to the poles, either the South Pole or the North Pole, then the intensity of sunlight falls, and therefore the amount of energy captured by the process of photosynthesis declines, so the available energy to ecosystems, food chains, and food webs is less at the extreme latitudes and greatest at the equator. If we move to oceans and aquatic systems, large lakes, then we have a different issue, and that is the depth of water. So light will only penetrate to a particular depth of water, and the penetration of that light also depends upon its wavelength. There's a difference between open oceans and coastal waters in how light penetrates, but the limits on the depth of the penetration of light will therefore set a limit on the capacity of photosynthetic producers to capture that light energy in the oceans and to begin food chains and food webs, making them available for consumption. There are some basic rules that we should think about when it comes to any discussion on energy. And that is that when energy is transferred from one store to another, which is essentially the idea of the sun's energy being captured in photosynthesis, or energy being moved from one trophic level to the next, that energy can be changed from one form to another. If we use the example of photosynthesis, then we begin with light, and the plants are able to capture it to form chemical energy. But in the process of doing so, of changing the energy from one form to another, you always have some of that energy is lost as thermal energy. It's not 100% efficient. Energy can be transformed from one form to another. Energy can neither be created nor destroyed, and the transfers of energy are not 100% efficient, and so there's energy loss. And these are the fundamentals in understanding why it is that tigers are rare and white-tipped reef sharks are rarely seen by most people. Appearing in front of you are the links to the playlist for this part of the course, the next video, and indeed the opportunity to subscribe.